In this video, we're going to be doing a Chapter 2 review, and we're specifically going to talk about names, formulas, ionic compounds, molecular compounds, and everything that we've covered inside of Chapter 2. So basically today we have 20 questions that we're going to be going over, and for each question I'll read what it says and what it asks, and then feel free to pause the video anytime to try to solve the problems by yourself, and then after a few seconds I'll showcase the answers. So we're going to start off with question number 1. So what is the first step in naming an ionic compound? And as we just said, feel free to pause the video and try to solve these by yourself. So for the answer for question number 1, so the answer to what is the first step in naming an ionic compound, so the answer is the first step is to identify the cation, which is the positive ion, and then the anion, which is the negative anion. So this is question number 1, and moving on to question number 2, when naming or writing the formula for a binary molecular compound, how do you know which element to name or to write first? And for the answer, the element that is closer to the bottom left on the periodic table is usually named or written first instead of a binary molecular compound. So when trying to name or write the formula, you should always have the one that is to the bottom left written first. So that summarizes question number 2. For question number 3, we need to classify the following compounds as ionic or molecular and justify your answer. So here on the left in this picture we can see there's many different compounds, and all we need to do is just classify if it's ionic or molecular. So for the first one there is Na3PO4, for the second one we have CaCl2, for the third one we have CH4, and for the last one we have HCl. So once again, feel free to pause the video and try to solve it by yourself. And for the answer, for Na3PO4 it's ionic because it contains a metal and also a polyatomic ion. For the second one, which is CaCl2, is ionic because it consists of a metal and also a nonmetal. For the third one, which is CH4, it's molecular because it consists of nonmetals. And for the last one, which is HCl, it's also molecular because it is composed of nonmetal atoms. So that summarizes question number 3. For question number 4, does the compound sodium nitrate, which is NaNO3, contain ionic bonds, covalent bonds, or both? And for the answer, sodium nitrate contains both ionic bonds because it's between Na plus and also NO3, and it also contains of covalent bonds within the group of NO3 group. So inside of NaNO3, it is an ionic bond because the sodium and the NO3, they're both different, so that's why when they combine, it creates an ionic bond. And then it's also a covalent bond because inside of the NO3, it's all nonmetals. So once those combine, then it becomes a covalent bond. The answer is that sodium nitrate contains both. And moving on to question number 5, how do polyatomic ions differ from simple ions? And for the answer, polyatomic ions are composed of multiple atoms bonded together that act as a single charged entity, while simple ions consist of one single atom with a single charge. And moving on to question number 6, how many calcium ions are in one formula unit of each of the following ionic compounds? So here we just need to see how many calcium ions are in each of the formulas. So for the first one we have CaO, for the second one we have CaBr2, for the third one we have Ca3 and N2. So for the answer, in the first one, which is CaO, there is one calcium ion. In the second one, which is CaBr2, there is also one calcium ion. And the third one, which is Ca3 and 2, it is 3 calcium ions. So that summarizes question number 6. And for question number 7, when an ionic compound is named or its formula is written, which ion is placed first, the anion or the cation? So this is a really simple problem. The answer is obviously the cation is placed first, and then after that it is followed by the anion. And this is in the name, so when you pronounce the name you're going to see this, and also when you write the formula. For question number 8, list 3 physical properties that can be used to distinguish between an ionic compound and also a molecular compound. So for the answer, some of the different things that you can use are melting points, electrical conductivity, so inside of water does it conduct electricity, and also the solubility. And there's also a few more that we didn't list here, but these are just 3 physical properties that you can use. For question number 9, use what you have learned about bonds to explain the conductivity or non-conductivity of molecular substances and also ionic substances in liquid form, in solid form, and in an aqueous solution. So for the answer, ionic compounds conduct electricity when they are in an aqueous solution because the ions are free to move. So once they're free to move, then that's why they conduct electricity. Inside a solid form, they do not conduct electricity because the ions are in fixed positions and they're also in that crystalline lattice structure. So once they're in that crystalline lattice structure, it's really hard for those ions to move. And inside, for molecular substances, they generally do not conduct any electricity because they do not have any ions. So they have no charged particles or atoms. So moving on to question number 10, explain why neither solid ionic compounds nor solid molecular compounds conduct electricity. And for the answer, solid ionic compounds do not conduct electricity because the ions are not free to move. So as we said in the last slide, they have that crystal lattice structure, so it's not free to move when they're inside of that solid crystal lattice structure. And for the solid molecular compounds, they also do not conduct electricity because they do not contain any charged particles. For question number 11, explain why molecular compounds tend to have relatively low melting points even though covalent bonds are relatively strong. For the answer, molecular compounds have low melting points due to the relatively weaker intermolecular forces between the molecules, and not the covalent bonds within the molecules. So the covalent bonds within the molecules are relatively strong, as we said, but the intermolecular force within the covalent bonds are relatively weak. So that's why molecular compounds have low melting points. For question number 12, how does the pH of an acidic solution differ from that of a basic solution, and what causes the difference? And for the answer, the pH of an acidic solution is below 7 due to a higher concentration of hydrogen ions, and while the pH basic solution is above 7 due to a higher concentration of hydroxide ions. For question number 13, according to Arrhenius' theory, how do acids differ from bases? And the answer, so according to Arrhenius, acids are substances that increase the concentration of hydrogen plus ions inside of solutions, while bases increase the concentration of hydroxide minus ions. So inside of acids, you're always going to see the hydrogen ion inside of the formula, and inside of bases, you're always going to see a hydroxide ion inside of the formula. For question number 14, how does the density of ice compare with the density of water? And how does this property affect the environment? For the answer, ice has a lower density than water because its molecular structure is more spread out inside of the solid form. And this allows ice to float on top of water, which helps isolate, and this allows ice to float on top of the water. So there's always like a thin layer of ice on top of the water, and during the winter, so aquatic life still can remain living since there's still water underneath the ice. For question number 15, explain why the covalent bond between oxygen and hydrogen is polar. And for the answer, the bond is polar because oxygen has a higher electronegativity compared to hydrogen, and this causes the electrons to be shared unequally and creating a dipole. And in this case, oxygen would have that more negative charge, and then those hydrogen atoms would have a more positive charge. For question number 16, inside of your notebook, name each of the following substances. So we have a few different ones here on the left. So for the first one, we have MgCl2. For the second one, we have Al2, and then inside of the bracket, we have CO3, and then 3 of them. For the third one, we have CaO. For the fourth one, we have NH4, and then 2 of them, and also S. And for the next one, we have HCl, and then for the last one, we have SBr2. So for the answer, for the first one, which is MgCl2, it's magnesium chloride. For the second one, which is Al2 and then CO3 and 3 of those, it's ammonium carbonate. And then for the third one, it's calcium oxide. For the fourth one, it is ammonium sulfide. For the fifth one, it's hydrochloric acid inside the aqueous form. And for the last one, we have sulfur dibromide. For question number 17, inside of your notebook, provide the chemical formula for each of the following compounds, and then also omit the state of matter. So for the first one, it is ammonium oxide. The second one is barium hydroxide. For the third one, it's sodium phosphide. For the fourth one, it's silicon tetrafluoride. For the fifth one, it's sodium phosphate. And for the last one, it's ammonia. So we need to find out the chemical formula for each of these compounds. So for the answer, The first one is Al2O3, the second one is Ba, and then 2 hydroxide ions, and then for the third one it's Na3P, for the fourth one it is SiF4, for the fifth one it is Na3PO4, and for the last one, which is ammonia, it is NH3. For question number 18, when the following pairs of elements combine, they form ionic compounds. So use the periodic table to work out the formulas of the ionic compounds formed. So for the first one we have barium and fluoride, for the second one we have bromine and potassium, for the third one we have nitrogen and sodium, for the fourth one we have magnesium and phosphorus, and for the last one we have calcium and sulfur. So for the first one, the answer is BAF2, for the second one the answer is KBr, for the third one it is Na3N, for the fourth one it is Mg3P2, and for the last one it is CAS. So for question number 19, oxygen has 6 valence electrons. So how many valence electrons does the other elements have in the following oxides? And then name each of the following oxides. So there's 3 different ones that we have here. The first one is Na2O, the second one is MnO, and for the last one we have PbO2. And for the answer, sodium has 1 valence electron, and the oxide is called sodium oxide. For the second one, magnesium has 7 valence electrons in MnO, and the oxide is called magnese, and then 2 oxide. So that means magnesium has multiple different cations that it can have. And for the last one, lead has 4 valence electrons in PbO2, and the oxide is called lead IV, and then oxide or plumic oxide. So in this case, magnesium and also lead both have multiple different cations. That's why we're using the Roman numericals, so that's why we can name them differently. And for our final question, which is question number 20, at room temperature, the pH of various solutions was found to be as follows. So for the first solution, it is 10.4, solution B, it is 7.8, solution C, it is 5.1, solution D is 7, and solution E is 2.8, and solution F is 11.2. So we need to identify each solution as either acidic, basic, or neutral, and then which solution is the most acidic and which one is the most basic. So for the answer, solution A is the most. So for solution A, it is basic. For solution B, it is also basic. For solution C, it's acidic. For solution D, it is neutral. For solution E, it is acidic. And for solution F, it is basic. And the most acidic one out of all of them is solution E, and the most basic one out of all of them is solution F. So that summarizes all the practice questions for this video, and to just sum up, we completed a whole review of everything we covered inside of chapter 2. And in our next video, we're going to start with our next and new chapter, which is chapter 3, and it's also our final chapter inside of chemistry. So thank you for watching from Try to Be Useful, and we'll see you in our next chapter 3 of chemistry.